Hi Elizabeth, thank you very much for your question. And yes, I fully understand the difficulty and confusion around the algebra of simplification. If it helps, I'll do a few examples and see whether that solves some of the issues you might have. So if I had y equaled x squared and then 4x minus 1 to the power of 8. So u is going to be x squared and u dash will be 2x. And v is going to be 4x minus 1 to the power of 8. And v dash is a chain rule. So it's going to be 8, 4x minus 1 to the power of 7, and then the derivative of the inside, which is 4, gives me 32, 4x minus 1 to the power of 7. So dy dx will equal u times v dash plus v times u dash, which I like to use coloured pencils, and I'm now going to do u times v dash, which gives me 32 x squared bracket 4x minus 1 to the 7. So I'm always going to put numbers, letters raised, brackets at the end, plus this times this, which is 2x, 4x minus 1 to the power of 8. Now it's a matter of looking for common factors. I can see in the 32 and the 2, there's a common factor of 2. Between the x squared and the x, I've got a common factor of x. And between the 4x minus 1 to the 7 and 4x minus 1 to the 8, I've got 4x minus 1 to the 7. And then if I take those common factors out, 32 divided by 2 is 16, x squared divided by x is x, and all of that's gone. Plus the 2's gone, the x is gone, and 7 of these brackets have gone, which leaves me with one lot of 4x minus 1, which gives me a final answer of 2x, 20x minus 1, 4x minus 1 to the power of 7 is going to be the final answer. Okay, a second example. Y equals e to the x cos of 3x plus 1. Whoops. So u equals e to the x and v equals cos of 3x plus 1. So u dash, the derivative of the exponential e is e to the x, beautiful, and the derivative of a cos is negative sine of 3x plus 1, but because this is a chain rule, I've got a 3 that I multiply by because the derivative of the inside is 3, that's minus 3 sine 3x plus 1. Okay, so dy dx is going to equal u times v dash plus v times u dash, or I can do my cross multiplication. So I've got minus 3 e to the x sine of 3x plus 1 plus this times this e to the x cos of 3x plus 1. And that's going to be the only thing that I have is e to the x, that is a common factor. So minus 3 sine of 3x plus 1 plus cos of 3x plus 1, and that's the final answer. Okay, a couple more examples. If I had y equaled x squared square root of 2x plus 1, so I've made this nice and easy. So u equals x squared, u dash equals 2x, v equals 2x plus 1 to the half, v dash equals a half, 2x plus 1 to the negative a half, and this is a chain rule, and the derivative of the inside is 2, and nicely that 2 cancels with that half to leave you with 2x plus 1 to the negative a half. So y dash will be u times v dash plus v times u dash. So u times v dash is x squared, 2x plus 1 to the negative a half, plus 2x. 2x plus 1 to the positive a half. Okay, now looking for common factors. I can see that I've got an x in there and an x in there, so I can take an x out as a common factor. I have a 2 here, but I don't have any numbers there, so the 2 will stay in. Of my 2x plus 1s, I've got negative a half as a power and positive a half as a power. The bigger number is negative a half. So I'm going to be left with x, and this whole bracket came out as a common factor. And then I'm going to be left with 2, and I had 2x plus 1 to the half, but I took out a common factor of 2x plus 1 to the negative a half. The difference between a half and negative a half is 1, so I'm going to be left with 2x plus 1 on the inside. So now to clean all this up, I've got x, 2x plus 1 to the negative a half, x plus 4x plus 2, and my final answer is going to be, the x will stay up top, this will go downstairs, and this here I've got 5x plus 2 as my final answer. And the last example I'll do with you involves a square root, but it will include a fraction. So y equals e to the 3x, the square root of 3x minus 1. So u equals e to the 3x, so u dash equals e to the 3x, but it's a chain rule, so I'm then multiplied by 3, and my v is equal to 3x minus 1 to the half, so v dash is going to be a half times 3x minus 1 to the negative a half times 3, because the derivative of the inside is 3, so that's me 3 on 2, 3x minus 1 to the negative a half. Okay, now I'm ready to put it all together. Y dash will be u times v dash plus v times u dash. So u times v dash is 3 on 2 e to the 3x, 3x minus 1 to the negative a half. So you'll notice I put my number first, then I put something to a power, then I put my brackets at the end. Plus 3 e to the 3x, 3x minus 1 to the positive a half. And now I need to look for common factors. I can see a 3 and a 3, so I'm going to take the 3 out. I've got a fraction of a half, so I'm also going to take the fraction out. Always, just as a general rule, take out the denominator, and that will put your fraction out the front, and inside here I'll have no fractions left. Much easier to deal with. I've got an e to the 3x in both of them, and of my 3x minus 1, I've got a negative a half, I've got a positive a half, the smaller of those is the negative a half. The 3 half went out the front. The e to the 3x went out the front. All of this went out the front, so I'm left with 1. Because it's a division process when we take out the common factors, and 3 over 2 divided by 3 over 2 is 1. Remembering that when I multiply this, I need to end up back up here, and 3 on 2 times 1 is 3 on 2. E to the 3x times 1 is e to the 3, etc. Plus. I took out the 3, but I also took out a half. So 1 divided by a half is 2, so I'm leaving a 2 in here. Remembering when I multiply this by this, I've got to get 3, and 3 on 2 times 2, the 2's will then cancel. And I will have e to the 3x goes out the front, and then I've got 3x minus 1 to the power of 1, because the difference between a half and negative a half is 1. So what have I got? 3 on 2 e to the 3x, 3x minus 1 to the negative a half, 1 plus 6x minus 2. And now I can clean it all up by leaving the 3 upstairs, putting the 2 downstairs, leaving the e to the 3x upstairs, putting this downstairs, and then this gives me 6x minus 1. And that's my final answer. Okay, Liz, I hope that helps. Remember that if you go to the website, you will see on the website, in the chapter to do with topics, calculus, differentiation, product rule. You will find lots of examples I've already completed, and here you'll also find some product rule, simplification 1, simplification 2, some tips and other questions in chapter 9 completed. And you'll also find that on the orientation page, I have worked examples of the chain and product rule handout sheet already up there for you to look at. So here are all my solutions to the product rule questions. If you've still got questions, please send me an email and we can work out how to answer specific questions. Cheers.